through this. And 12.2 is on a different type of angle, an angle that is different than what we did in 12.1. They are called inscribed angles. And the biggest difference is that in section 1, we dealt a lot with things called central angles. When it's a central angle, the vertex or the angle of that, the center point of that angle is in the exact center of the circle. In 12.1, the central angles were equal to the arcs they intercept. The inscribed angles that are in section 2 are different because they have a vertex that is on the edge of the circle. I kind of want to show you a couple pictures. This picture here, if you notice the vertex, the V part of that angle is on the edge of the circle. This is an inscribed angle. Inscribed angles are different than central angles. I'm looking for a central angle example. This is a central angle. This is an inscribed angle. Inscribed angle has the edge of your vertex of your angle on the edge of a circle, whereas the central angle is at the exact center of the circle. Now there's a huge difference mathematically between these two things, which is why I color-coded this one in blue and this one in red so you would know the difference. The central angles are going to be equal to the arcs. They're going to be the exact same, whereas inscribed angles are going to be half of the arcs they intercept. If I think about half and I think about, I can either half something or I can double it, and they can be the same thing. So sometimes I'll use half and sometimes I'll double depending on the situation that I'm in. If you half something, a lot of times it only works, it's easier if everything is even. Like if you're halving 2x, that's easy because that's 1x. But if you're trying to halve 3x, it might be easier just to double something else. And that's why I would double something instead, or multiply by 2. The last thing that we have in our notes is talking about the radii of circles. If you know that you have a radius of a circle and another radius of the same circle, those two, we don't say radiuses, we say those two radii. This is the plural form of the word radius. Both of the radius, both radii, will be the same. They're going to be congruent or equal in measure, and that can create isosceles triangles, which is what we're going to use to answer some of the questions. So, with that being said, the examples I've chosen for you that you have the worksheets on are number 1, number 6, 8, 15, and 19. So I have 5 examples, and some of them will go really, really, really quickly. Okay? This is number 1 on your worksheet. The first thing it says is figure out what x is. And they tell you that this arc is 90 degrees. X is a certain type of angle. If you don't know what kind of angle it is, I'm going to write it down here just so that you should be thinking about it. This one is called, the edge is on the edge of a circle. It is inscribed. Is inscribed equal? No, it's half. So if this is 90 degrees, x is going to be half of the arc it intercepts. What is half of 90 degrees? If you know that, you know the answer. The answer would be, if you know it, say it out loud. I agree. That's it? Yes, this is a reason why I want to give this as a chapter test. Because if they are this easy and you understand what you're doing, why not get a good grade on the test score, right? Like literally you should be asking for this to be a test because you want to raise your grade. Number 6. Then what they do is they start incorporating some things we talked about from section 1. In section 1, we talked about if you see a dot right here, that's the center. And if you have a line going across, this is called a chord, that goes across through the center, this must be a diameter. I'm just going to write down that that's a diameter. It has to be a diameter because it is a segment that goes through the center. And I know it's the center because there's a dot right there. Diameters, you're supposed to be thinking that they have a total sum of so many degrees. And we wrote it in our notes last time, but diameters are 180 degrees. Now they're asking for the measure. M stands for measure of angle C. When you see C like this, they're saying, what is this? That's the question. What is this angle with the vertex being C? Well, they gave you that this is arc is 140. I bet you could figure out what arc DB would be. Figuring out that since this is a diameter, you know that whole thing's 180. This arc DB should be 40 degrees. Got to do that first. And then angle C is an inscribed angle. The edge is on the vertex. The vertex is on the edge of the circle. Are they equal? No. It's half. How much is half of 40? If you do half of 40 degrees, it's equal to 20 degrees, which is how we worked it out. Fairly simple though, right? I mean, we haven't even needed to use a calculator. We could do a lot of it in our head. What we've been doing is we've gone from the arc over into the angle, but some of the questions will go from the angle to the arc. So now they say, what is arc CE? And so I just want to kind of highlight what CE's arc looks like. That's CE. They're trying to trick you a little bit on number 8. Why? Because they gave you the inscribed angle 25 degrees. And so using the 25, you should easily be able to figure out what DE is. Let me switch to blue. What arc DE is. If this is 25, so remember arc, the inscribed angle is half. If this is half, this would be double whatever that is. So in this case, I don't have 25. What do I have to do? I have to double it. 2 times 25 is 50 degrees for that angle. Well, that's still not the answer to the question. The question is what is arc CE? And then notice that there's a center, and then this must be a diameter. You guys should know that if this is a center and that's a diameter, that a diameter has a total of 180. I bet you can figure it out what it is now. If you know what it is, go ahead and say it out loud. I heard somebody say 130. You're right. If you don't know how we got it, we're saying that the diameter is 180 minus the 50, which makes 130 degrees. Fairly simple. How does it get harder? They're going to throw in some algebra. When they throw in the algebra, some of you will freak out, but it's the same concepts as what you've been doing. So, for example, this says it's 80 degrees. This says that this is the angle is 11x plus 7. And so you may want to think that this and that are the same, but they are not equal to each other. This is half of that. So if this is 80, if this arc is 80 degrees, half of that means that this angle here has to be 40 degrees. So if I want to know what x is equal to, which is what they're asking me to find, then I have to set 11x plus 7 is equal to 40 degrees. And solve that. So when I do this, I'm going to subtract 7 from both sides. I'm going to divide by 11 since that's multiplying by x. I'm going to divide this both sides by 11 so I get x by itself. 1x is x. 33 divided by 11 is 3. If it gets way more complicated than that, sometimes, I want to show you the same problem. Sometimes what you might want to do is you may want to double the smaller inscribed angle to equal its arc. You could have found the same answer by doubling 11x plus 7 equaling 80. Just to show you real quick, you could have done this as well. 66, and x would also be 3. So you can do it by doubling, or you can do it by doing the half. It is up to you, whatever comes natural. So I think number 19 is the hardest question. And it takes like 3 steps to get to the answer, and that's why I picked this one. It said angle, in circle A, angle CBD is an inscribed angle. CBD is an inscribed angle. Yep, yes, I agree. It's 36 degrees. What is the measure of angle CDA? They C, then D, then A. C, then D, then A. They're asking for, what's this angle? So what we have to do is several steps, and here are our choices. And the way I'm going to do this is if this is 36 degrees and it's inscribed, then I can figure out what this arc is. 36 doubled makes this 72. Because that would make this half of that. That means the central angle has to be 72 degrees. Right now, when I look at my choices, I can tell why they picked A and why they picked B as a distractor. They put those there because there's a 36 and there's a 72, the first 2 steps that I did. A lot of times they put those as choices because they're trying to see if they can distract you with the most common wrong answers. And this is where that last sentence goes into play. AC is a radius. AD is a radius. These 2 radii are congruent to each other. What that does is it creates an isosceles triangle. If that's 72, these 2 sides are the same, then these 2 angles across from them should be the same. We learned that in chapter 3. Well, if that's 72, how much is left between these 2 congruent angles? 180 minus 72 is, borrow 0, is 108 between both of these. Well, we got to cut that into 2 equal pieces. Divide it by 2. 2 goes into there 5 times. 2 goes into there 4 times. That means this angle has to be 54 and this angle has to be 54 for those 3 to add up to 180 degrees. The answer that I choose is C in this case, and I'm using an inscribed angle, I'm using a central angle, and I'm using an isosceles triangle for that. That takes a lot of steps. But if that's as hard as it gets, that means the test that we give you on this should be pretty easy. Let's stop your notes right there.